Hey everybody, Matt Morgan here. In this video, we're going to talk about atoms, moles, dimensional analysis, and do Wiley problem 05-05. So here's the problem. A piece of copper wire has a mass of 18 grams. The same number of atoms of a precious metal has a mass of 30.6 grams. What is the metal? The molar mass of copper, 63.55. So questions like this require some organization and maybe some interpreting. You don't want to just start cranking numbers out until you know your given information and you know, more importantly, what your goal is, where you are going. So here's our goal. They ask, what is the metal? So we want to find the identity of this unknown metal. We're not completely there yet, but that gets us closer. With most chemistry problems, following units will be the key to successfully solving it. What we want to do is find the molar mass of the metal. The units we're looking for are grams per moles. Once we have grams per mole, we can look at the periodic table and match that molar mass with the atomic masses that are listed on the periodic table. That will allow us to find what the metal is. So, organizing our given information, mass of copper 18 grams, they give us the molar mass, 63.55, but if they didn't give us that, we could look it up. The mass of the unknown metal is 30.6 grams. The copper and the unknown metal have the same number of atoms. That's an important phrase in this problem. So this is a common type of chemistry problem. It gives two substances that are linked by the same number of atoms, the same number of molecules, etc. Most of the time, we can work these problems in two steps. In fact, there are multiple ways to find the solution to this. This is just one way. It works for me because I like organizing the information this way. So in step one, we're going to deal with the copper. We'll take that given information and we'll find the number of atoms. Step two, we'll take that number of atoms, which we know is the same, and find our molar mass. Starting with the copper. So what do? Most problems in Chem 1, when in doubt, convert to moles. If you've talked to me at all, you know I say that all the time, because most of the time converting to moles will get us closer to our final answer, and converting to moles is therapeutic. It's better to be doing something than just sitting and staring at the problem. So the problem specifies the same number of atoms. We'll convert to moles, then to the number of atoms. We'll use Avogadro's number to convert from moles to number of atoms. Our target unit is atoms of copper. I always specify the target unit whenever I do any kind of dimensional analysis problem. There's our grid. There's our given information, 18.0 grams of copper. I apply the molar mass, 63.55, to put grams on the bottom because I want grams to cancel. Grams are not in our target unit. If 63.55 grams goes on the bottom, 1 mole goes on the top. Okay, we're closer now. We're to moles. Now I have Avogadro's number. 1 mole on the bottom because I want moles to cancel. Then we put our 6.02 times 10 to the 23rd atoms on the top. Before crunching numbers, we look at our units. Grams cancel, moles cancel. We are left with our target unit. Now I will multiply numbers on the top, divide numbers on the bottom. Go ahead and do this yourself. Don't trust my math. I'll give you a couple seconds. You probably want to pause the video while you do it. But I get 1.705 times 10 to the 23rd atoms. I'll carry a few extra digits. Since we're finding the identity of an atom, significant figures are not really important, but I like to carry extra digits anyway. So that is the end of the first part of this problem. In part 2, we'll identify the unknown metal. We will start with our 1.705 times 10 to the 23rd atoms, and we know this is the number of atoms of the unknown metal. We'll convert this number to moles and combine that with the 30.6 grams of our unknown metal. Our target unit, atomic mass, molar mass, same thing, grams divided by moles, grams over moles. Set up my dimensional analysis grid. I'm going to put that 30.6 grams on the top because my target unit has grams over moles. Okay, I want to put 1 mole on the bottom, which means I have to put Avogadro's number on the top. So right now, as of this point, nothing has canceled, but I do have grams over moles with that extra atoms. We need that atoms to go away because our target unit is grams per mole. So I'll take that number of atoms that we calculated in the previous part, and I'll put it on the bottom because we want atoms to cancel. We want to be left with our target unit grams per mole. Sure enough, atoms cancel. Now I'm at my target unit. I'll crunch my numbers. 30.6 times 6.02 times 10 to the 23rd divided by my number of atoms calculated before, 1.705 times 10 to the 23rd. Punch that out in your calculator. Hopefully your answer matches mine. I get, to 3 significant figures, 108 grams per mole. Now we need to look on the periodic table for atomic masses. Which atomic mass is the closest to 108 grams per mole? I scan and I see that it's silver. The atomic number is 47, the atomic mass 107.9, really close to 108. There's nothing else that's close. And the problem said that the unknown metal was a precious metal, and silver fits that description. So that's how you do that problem. As always, contact your course instructors if you have any questions.